index 0, index 1, index 2, index 3, right? So far we're over here. And then if column is 1, then we plus 1. So this is where the row left off when we did row times 3. Now we add 1, then we come here. Right? So now let's go here. And on the grid, that's the one that we want. Welcome back to Arcade. I am Super Tommy, and this is part 5 of our multiplayer tic-tac-toe game using Colyseus and Phaser 3.50. Now, in this part, we're going to actually check for the winner of a tic-tac-toe board game. In the last part, we were enforcing players' turns so that if it's the first player's turn, they're the one that can go and not the other player. So here we're going to check when there's a win that happened on the tic-tac-toe board. Now in tic-tac-toe, you can win in a few ways by just connecting 3 of your own piece. So 3 X's either across each row, or up and down each column, and the diagonal. So you've got 3 rows, 3 columns, and then 2 diagonals. So that's a total of 8 ways that you can win. So in this video, we're going to go with a brute force approach, since we know we just need to check each row, each of the 3 rows, each of the 3 columns, and the 2 diagonals for the same piece in all 3 slots. So there's other ways you can do this too. If you're doing Connect 4, which is similar, you wouldn't want to do it this way since it's a much bigger board and you would need to figure out a lot more of all the possible ways you can win. But since tic-tac-toe is a bit simpler, we're going to do it this way. So the first thing, let me just make myself smaller. First thing we're going to do here is add a new command to our server. So where we're determining next turn before that happens. So once we put down a piece, and then we're going to check if we possibly could have won. If not, it's the next player's turn. If we did win, then we mark that we won, and then our client is going to show you a game over screen. So either you won or you lost. So let's go to our server. And we're going to go to this player selection command. So this is when the player makes a move. So either you click on a cell here and you put down an X or an O, and then this is the code that gets called. And we do a next turn command to move it to the next player's turn. So now before we do that, we just want to check that the game isn't over yet, that no one player has won. So let's make a new command in our commands folder here. Make a new file. Let's call it check winner command, and it's going to be similar to this command here. So let's actually just take this, or rather we want these. We know we're going to need these imports here, and then export. We'll do a default class player check winner command extends command. Now we're going to have a payload as well. Let's see, type payload, and let's see. So we're going to want anything actually. We may not need anything. So let's just try without nothing to start. So execute is what's going to get called on that command. Just look at this, right? Okay, check winner. Just check some notes here. Okay, so we have our board state. So this dot state dot. All right, we need to tell it what this is, which is I tic-tac-toe state. There. Let's make sure this import. So if you're importing normally without the tilde, that's just that shortcut. Just make sure you import that type here. Do that, just double check. Command, state is the first one, payload is unknown. I think we don't need anything for payload, but let's just say we put that there. So now this dot state, got the state, got the board. So this is the actual board. We want to check this board, and of course this board is an array. that we talked about in previous videos. Let's say one long array that represents our 3x3 grid. And so let's see. So first thing we want to do, let's make a new method here called determine_when. Right, so when we come here, when we execute, we're going to want to know if we won or not, right? So like we're going to be doing this. And then this determine_when is going to be where all the logic happens to check whether we've won or not. And then depending on whether there is a win, we're just writing some structure code here. So if there is a win, we are going to so to do is to set winning player, let's say, on our state. And then else we will go to new turns. So we're going to do new next turn command like that. And so let's just say this is always false. Right, starting this way, we can put this command in our player select immediately. So instead of this, I'm going to do check winner command. Let's get rid of that. So what we've done here so far is basically just filled in some code, but if we played the game as is, it'll be exactly like it was in our last video where we left off. So we've just added some structure here, but the way this is going to execute, because we've got default false, just return false every time, there's never a win. We've got the rest of the code working as it was before. So now we can fill in determine when. So first we want to know what these rows are. So like I talked about, there's 3 rows, 3 columns, and then 2 diagonals. So let's just call this winning, let's see, let's call this wins. These are different ways you can win. It's going to be an array. Now it's going to be an array of arrays. And each array in this array is going to be either the row, the column, or the diagonals. So let's do that. So let's see. I'm going to define this by row and column. So let's do the rows first. Right here. So if we have a win at 0, row 0, column 0, and then we're also going to want row 0, column 1, row 0, column 2. So this array here represents this row. And then now let's do the next one here. So this is going to be row 1, right? But still column 0, column 1, column 2. So that's row 1. And then here's row 2, or well, the third row, but the second index. So that's the same columns, but different rows. Okay, so that's the rows. And let's do the columns. This is up and down here. So that's the first row 0, column 0, still here at the top left. And now this is going to be row 1, column 0. So column 0, row 1. And then row 2, column 0. So this line right here represents this column. So this guy, this guy, this guy, these 3 guys. So now we want the 1 column over. Same row, but columns 1, same row, column 1, same row, column 1, right? So row 0, column 1, row 1, column 1, row 2, column 1. This is always 1, because 0, 1, 2. Now this one is going to be this one. So row 0, column 2, row 1, column 2. Row 2, column 2. So now we got the rows and the columns. So now let's do the diagonal. So let's do this diagonal first. This is row 0, column 0. This is row 2, or rather row 1, index 1, column 1. And then this is row index 2, column 2. So right here, this is this diagonal from top left to bottom right. Now we want the inverse from top right to bottom left. So let's do that here. So let's start at top right, so that's row 0, column 2. And then row 1, column 1 in the middle, and then row 2, column 0, right there. Great. Alright, so we can double check this when we do it and just see if our wins actually match. So there's a wins. So we're going to go through each win and then check the board. So with this, we're going to help ourselves here. So let's just start. So we're going to go through all our wins. So for I less than wins dot length. So these are the win lists, the win list that we just made, the wins list. And then each item is an array. And then in each one of these, so we're going through that. Then we want to go through each one of those rows and then check if the cells at that position, so like at row 0, column 0, row 0, column 1, or row 0, column 1, row 0, column 2, they have the same piece in it. So they all have X's or they all have O's. But so whatever it is, they have to be the same. They have to all equal each other. So let's go through another 4 here. And then this is, let's just call this a win. Just wins I. So win.length J. Now whenever you're doing nested loops like this, it's just got to remember that the I is the outer one and the J is the inner one. You can also use different counter variables that have I and J to make it harder to make a mistake. Okay, so now we have each win row, so it's one of these things. I'm looking at these. I'm going to go through each one and check that the piece in this cell is the same as the piece in this cell, and that the piece in this cell is the same as the piece in this cell. Whenever any one doesn't match, we know that whole row or column or diagonal does not have a win. Okay, so win J is going to have a cell. So let's just call cell. Now we want to check against the next cell. And what we can do instead is actually just start at 1 and then check against the previous cell, since we know for sure, well, we made this here, that there's always going to be 1 before it if we start in the middle, or start at the second one. So let's start at I, we're at the start at 1, and then we're going to do previous cell, let's call it prev cell, which is going to be win J minus 1. So it starts out at 1, J minus 1 is going to be 0, so that's like over here, let's say. And this, the current cell is just J, and we want to make sure that the value on the board, so this is the state.board, which is one array, or rather this is one array, array of piece types. And so let's just do this. Let's just go in here. Just cell, and cell is either empty, X, or O. Now to make this easier for us, and we've got to call this a lot, we can make a helper function here. And we're going to call this get value at, and we're going to give it the board rather, which is going to be number. That's fine. We could probably make this cell, but let's just say number. Give it a row, which is a number, and a column, which is a number. And it's going to return us whatever value in this board. So let's actually have some notes here just help us visualize, right? So these are the rows, these are the columns. And we're going to do some math here to figure out what, given the row and column, what the index is in our single dimension array. So let's get the index that we want based on the row and the column. So if the row number is 0, let's say, we know it's this. But let's say it's 1. Then it's this. And now we know each row is 3 columns long. So if we were to multiply 0 by 3, we get 0. And then let's say the column in this case is 0 as well. So 0 times 3 is 0. And then if we just add, right, add whatever column is 0, we get this one. Let's see if that works if it's row 1, column 1. Let's say row 1. 1 times 3 is 3. So 0, 1, 2, 3. Now we said row is 1, column is 1, so we want the middle guy. So row 3, or rather 1 times 3 is 3. And then plus column is 1, it's going to be 4. So index 4, 0, 1, 2, 3, 4. So that's the basic formula. So let me just write it out here. Row times 3, which is the length of the row of the grid, plus column, gets us the index into the array. So if you look here, if our array is made to look like a grid, right, this is just one long list. So come up here. It could just be this, right? This is just one long list. And we separate it by 3. Each third piece is the new row, right? We get this thing. And so let's just say that row 1, column 1 again. Row 1 times 3 is 3. So if we go back here, so index 0, index 1, index 2, index 3, right? So far we're over here. And then if column is 1, then we plus 1. So this is where the row left off when we did row times 3. Now we add 1, then we come here, right? So now let's go here. And on the grid, that's the one that we want. So there roughly proves it out. You can try different numbers. But you'll see this is the correct formula here to go from row column coordinates to a index in our board array, which is one single dimension array representing our 3x3 grid. Okay, return out this index. Or actually rather, return board into the index, which gives us a value, which is a number. Okay. So here, instead of that, what we're going to do is let's get the previous value from the previous cell. So get value at this.state.board previous cell.row previous cell.column. So we're going to get a number value here, which is what enums are. Enums are just starting at 0 and it goes to whatever it is. Enums and numbers are usually interchangeable, unless you're using string enums. Now let's get value, which is going to be the cell value. So let's just call the cell value. Get value at this.state.board, and then this is cell.row, cell.column. Okay. So if at any point these are not equal, we can return false, basically. So let's just try this. If previous value is not equal to cell value, so let's just look at it. Let's just go for this one. So if we're over here, we're going to look at previous value. Let's say this is empty. And then this value is also empty. So they are actually equal, but they're empty. And you can't have winners if it's empty. So, and in this case, let's say, and previous value not equal to, this is our enum dot empty. No. So if previous value not equal to cell value and it's not empty, we actually have no win here. So let's actually come out here and say has winner. We'll just say has winner true. Oh no, for this row, not the whole thing. For this row. So has winner is false here. Then we can break out of this inner loop. So this inner for loop. And then if we do have has winner, then we simply return the winning row, which is the winning, not row, but the winning combination, row, column, or diagonal. All right, so let's look at this again. So let's just try running it, right, in our heads. For this first row, we're at 0 row 0 column and 0 row 1 column. So we come in here, j is 0, which is here, j is 1, which is here. We get the value. These are both empty. So previous value is empty, not equal to cell value. So that is false. And not equal to empty is false. Oh no, this shouldn't be an or. See, gotta double check. Or equal to empty. So if previous value is empty, winner will always be false. If it's empty, there are no winners. And if the previous value is not equal to the current value, that means the two values are different, we have no winner. All right, let's do this again. We're here, we're looking at this one, which is empty. Now we're going to compare it against the previous, which is also empty. So when we come here, they are equal because they're empty, but it equals empty, so we go to false. So previous not equal to current, or previous is empty, no winner. Now let's say this is an x. Let's refresh this. Let's say this is an x. Then let's say, let's see if I connect to the same one. Yep. Let's say this is an O. Okay. So let's say we have this here. This is also no winner, but let's just check here. So we go to 0, or rather we go to 1 in this winning row. So this is 1. We check previous is an x, and the current is an O. So previous value x not equal to O. True. Or previous value equal to empty. False. True or false goes in, no winner. On the other hand, just put some moves down here. Now let's check if we were to do this one. So this is row 2, column 0. We're going to go through this. So we're going to check this up and down, which if you recall, I believe it's so row 0, 0, row 1, 0, it's this guy. Right, row 0, 0, row 1, 0, row 2, 0, column 0. So if we do that, here is 1, right, in our inner for loop here, j is 1, previous is this, so previous is x, cell is x, so previous not equal to cell, false. X equal to x, so this is false. Or previous, this is equal to empty, false. So if false or false, so this is not true. False or false is not true. It does not do this. It goes to the next one. So it comes here, right? So now this is currently empty. So it's going to do previous, which is this middle one now, and this new one. So previous is x, cell is empty. Previous not equal to cell, true. X is not equal to empty. Previous equals empty, false. But true or false is still true. It goes no winner, false. If I put an x down here, you're gonna, if we just run through it again manually, you'll see that it starts here, x, previous, cell, not equal. They are equal, so this is false. Previous is not empty, so this is false. False or false, not true. Does not go into this if, so goes to the next thing, which is now this is cell current, this is previous, and so now it does previous not equal to cell. That's is false because x is equal to x, and, or previous value not equal or equal to cell empty, which is false because this is an x. So this is false. This is also false. Doesn't go in here. Comes out. Checks the j less than win.length, and in this case we're done with this this winning combination, this potential winning combination. Break out of that. For loop has winner is still true because it starts out that way. We come here, that's true. We return the win, and then we come here, win is true, and now we're going to have to set winning state. Right. So this algorithm basically looks correct. We'll only know when we actually try it, but so far so good. So this is the algorithm. Now let's come here. Let's do a console.log winner. Now for this video, I've actually started the terminal in here. Now this is the start server, npm run start server command. So let's come here, just refresh this since the server has restarted. All right, new game. So X, let's put an O, let's put an X here, put an O. Now we should see that this is a winner. And it does. Ta-da, winner. So this is good. This is what we expect. Yeah, well, refreshing not going to help. The game's not over yet. Currently, we don't have that logic. So far, it looks like this is working. So that's good. Let's close out this terminal. So what we want to do now is actually let our clients know that there is a winner, now, because we've picked one already. So now instead of doing next turn, we got to do a set winning player. Now we don't have this yet, but we're going to add it. So winning player is going to be the index of the player that won. And in this case, it's just going to be, it'll just be this.state.active player, because the current active player is the last one to make a move. We do this check every time you make a move, and they're still active player until next turn. Then we're going to put this into a winning player property. Let's go to Tic-Tac-Toe state. Come here, just do this type for the Colyseus schema. We're going to do winning player. We're going to set this to -1 to start, which means nobody is the winner. Let's come here to our interface and just add that as well. Okay. So let's see. Winning player is missing. Winning player. There we go. Okay, typos. Okay, so that's good. Now let's go to our command here. So we're going to do this.state.winning player gets the active player. Now Colyseus is going to automatically let all the connected clients know that winning player has changed. Now we have to account for that in our client code. Let's come to our server here. And so we have these property changes already. So let's do the same thing. We're going to do case winning player, this.events.emit. Let's just say winning player, player one, player one. And then the value, which is going to be the index of the player. Good, let's add a break here. And then we want to let the scene on the phaser side know about this. So on player one, on, we're going to have a callback. It's also going to be player index, just like the one above. Returns nothing. We'll take a context. It's optional. This.events.on, player one, callback context. So anyone listening to this, when this fires up here, we'll get notified. So let's go into our game. After we create the board, we listen for these events, listen for another one. So this.server.on player one. So let's just call this handle player one, and this is the context. Let's go down here. So the bottom of our game class, handle player one, player index. So you see we didn't do anything here, but we're going to do something. Basically, we can just log it out here, but what you could do here, just like a detour here, is show a message letting the player know it is their turn. Right, so I'll leave that one to you actually, because we're going to do something similar here with player one by doing a game over screen. That'll be in the next video, but right now we can show you how to know when it's you that won versus the other player that won. So let's go this.room, this.server.player index. So this is your player index equals player index. So if the player indices are the same, let's just say console.log you won, and then let's just say else console.log you lost. All right. Cool. Let's make sure. I think we're probably connected. And one other thing that we haven't done in previous videos that we should have done. Let's go to our Tic-Tac-Toe class on the server, the Colyseus server side. Now, Tic-Tac-Toe is a game of 2 players only. By default, this is the Colyseus monitor that we're looking at. We can have infinite clients here, right? Let me just expand this. But it's not actually true. This Tic-Tac-Toe, we don't want infinite clients. So you could build it that way to have spectators. But we're gonna just keep it simple here. We're gonna do this.max clients 2. So we'll never have more than 2 people connected to any single room or Tic-Tac-Toe game. All right, so now that we have that, let's just refresh this and refresh this. Brand new game, that's an X. Let's put an O here. Let's bring up the dev tool so that we can see the message we're looking for. We're looking for this you won, you lost. Okay, so it's X's turn. Let's say that. O is just gonna throw the game here. X, and let's see. Okay, field that change. I did not see the log, so that log did not happen. So let's see. Player index. It's your player index. Oh, player win. So these really should be a constant somewhere, an enum of strings, perhaps, so that you don't type it out and make typing typos. Just do a refresh here to make sure we got what? This guy's X? No, let's see. So we're gonna cover restarting the game later, so for now let's just keep this simple. We're gonna dispose this room while we're developing. Connect to a new room, connect to a new room. Now they should be in the same room. Okay, there's the X, there's the O, X, O, and then here we go. You won, this is correct, the X player won, and the O player lost. So there we go. That is checking the Tic-Tac-Toe winner algorithm. Now, just to review, we did it in check winner command, and this is the relatively brute force approach here. We just added all the possible winning combinations for each row, for each column, and then the 2 diagonals. And then what we did is we looped through each one of our winning combinations, possible winning combinations, each time after a player turn, and we checked that in each winning combination that the rows are always the same. Or rather, not the rows, the cells in each winning combination, possible winning combination, have the same values. If they're all the same values, they're good. If there's any empty cell in there, obviously that's not a win, can't win with empty values. And if they're not all equal, then you did not win. So if they're all equal, then you get a win. If you get a win, we set winning player on our Colyseus state, and then Colyseus will send that value down to all connected clients, which we handle in our server service class for winning player. And when that happens, we emit an event to whoever's listening, and in our case, our game scene is listening. And then when that happens, we decide if the winning player index is our own index, we've won. Otherwise, we've lost. Now that's it for this video. In the next one, we're going to add a game over screen and a way for you to then restart the game so you can play again. Now, if you enjoyed this video, do hit like and subscribe for more videos on making multiplayer games with Colyseus and Phaser.